Hello, and welcome to our Wednesday wisdom session today on blocking software supply chain attacks. I'm just giving folks a moment to file in, and then I'll quickly introduce our speakers. So grab a beverage of your choice, and I'll be back on in just a moment. Alrighty, welcome again, everyone. Excited for the session on blocking software supply chain attacks. I'm thrilled to introduce our speakers today, Pete Morgan, co-founder and CSO at Phylum, and Noah Simon, head of product marketing at Dazz. Should be an excellent discussion. And with no further ado, I'll turn it over to Noah. Take it away.
All right, thank you, Jordan. And thanks, Pete, for coming on today. Really excited for this conversation. Supply chain security has quickly become, one of the most hot button issues in the security industry, and also, in the eyes of the U.S. government, receiving a ton of attention. So excited to learn and get some insights from you. If you could do a quick intro and intro of who Phylum is, that would be great.
Sure. My name is Pete Morgan, and I'm one of the co-founders at Phylum. I came from a long history in most of the offensive side, reverse engineering, exploit development, applied crypto, that kind of thing. So mostly coming from offense and thinking about how attackers operate to emulate those attackers. We and my co-founders and a strong part of our team from Phylum also came from a very similar background, so definitely offensive minded, and I think we bring that into our product design. When we think about defending the software supply chain. We really built Phylum because we looked at the state of products that were around, right before 2020, and it's no surprise that when you talk about the open source, so the software supply chain, one of the big parts of that is the open source software that developers use and reuse to build their software products. At the time, it was well understood that vulnerabilities would be present in these open source projects. But because of the way things have changed with build automation and using pipelines and trying to get to reproducible builds, we find that we're reusing open source code in a way that extends these problems far beyond just software vulnerabilities. And we built a proof of concept and ended up finding some malware in the open source software supply chain. And this tipped us off to kind of thinking a little larger on what else could go wrong by reusing untrusted code from strangers on the internet in automation, and then seeing that basically the whole world was doing this. So we built Phylum to kind of come and analyze the software and develop defensive protections to stop attackers from using the open source supply chain to compromise organizations or individuals.
Awesome. Could you talk about some of the biggest challenges within software supply chain security? I know you mentioned, obviously, the adoption of open source is kind of a pretext to all these challenges, and how open source has become just so ubiquitous. But what are some of the specific challenges Phylum sees today?
Yeah, it's a great question. I would say, one, the sheer volume of what's being used and how much that's changed just in the last 5 years. So if you look at an average software project and you look at the dependencies used by that software project for open source packages, and you walk those down to the average dependency depth, you build a graph of all of those dependencies, that has exploded just in the last handful of years. The amount of dependencies an average project includes. We kind of see that as attack surface, right? Because if any one of those maintainers their account was compromised, or someone convinced them to add a new dependency, like you see that as the attack surface. And also we're seeing a lot of elements of the tools used for software development and dependency management and speeding up developers and making this a more enjoyable job for them are kind of built on conventions, not on security boundaries. When you use things like package managers, and those package managers can be something like npm for JavaScript or pip for Python, but they also could be Visual Studio Code's package loader. That's another package manager. There's a package manager for Git pre-commit hooks. There's package managers for just about everything. And the great majority of them on average just observe GitHub repositories and find out when those repositories get updated. And when you click a button or you hit the auto update button, it just pulls in new code off GitHub. And this kind of recreates that same problem of relying on code that we really don't know that if we should be relying upon. And then if an attacker gets access to that repository, what can they do downstream to developers that rely on them and those consequences? And that is something that we're seeing unfortunately expand and replicate faster and faster in the world. So trying to get in front of figuring out what is this code we're importing and bringing in, and how can we do so in a defensive posture where an organization can say, this is what we'll accept and this is what we won't.
Mm-hmm. Yeah, it makes sense. I kind of see it the way I kind of draw a comparison is, you know, the way computing environments became way more complex, right? You had kind of static computer environments with like workstations and
Right.
in defined company network perimeter, and then, you know, IoT came around, and then cloud, and then mobile devices, and suddenly everything's really hard to protect. And it's the same way in the world of software, right? You just mentioned the number of dependencies where those have blown up, and it just creates a larger attack surface to defend.
Absolutely.
Can you, so I saw Phylum put out a report just a couple of weeks ago with some really interesting trends. Could you talk about some of the new trends in your state of software supply chain report? I might have just messed up the title there.
No worries.
But yeah, some really interesting insights on attack behavior there.
Yeah, so the way Phylum kind of approaches these problems is we watch all of the package registries that are commonly used, and every time a new package is released or an update is released, we download that and analyze it from a static analysis perspective. We do dynamic analysis, all the author data we can figure out about who wrote the package, really every bit we can get our hands on. And that kind of gives us a pretty nice data set of what is being released, where is the state of software today. And we do put out these quarterly reports where we say, here's the trends we've been seeing, here's the attacks we've been noticing, right? And the probably most interesting part from our Q3 report was our targeted attacks went up nearly 50%. And that is, when we look at the names, like a big problem in the open source software supply chain is that we have to name things, and names have meaning here, right? If I want to go down and install requests from Python, it's a very popular library. Attackers know that's popular, so they can pollute around that name. And if I misspell requests in one of a dozen ways, that will step on someone else's package that has polluted around the namespace of that package, right? So by observing those name collisions, we can then draw back what are attackers, what are they interested in trying to target? Sometimes it's just very popular open source projects that would make a lot of sense, right? Just basically stack rank what are the most used packages by a package manager, and then typo squad or name squad around those. We've seen a lot more actually happening around companies. So a company name that might have an API or a package for developers to use, or even a company's products that include something similar like an API. And we've seen a huge explosion around things trying to target those, trying to get developers that might be relying on an API for a very popular company.
Yep, very interesting. Basically, domain squatting applied to
right
software.
And this comes with, pardon me, sorry, the parts I'm not mentioning, which are kind of consistent year, quarter to quarter to quarter, which is there's tons of malware being released. We're seeing something like I don't remember the exact number, but it ballparks to around 1,000 to 1,500 malicious packages a day. That's just what's going out in the ecosystem that Phylum detects right now. We're seeing a lot of activity in the author space. So in the author risk domain, people trying to emulate other authors or post attribute a package to another author who might have a stronger presence online and seem more trustworthy. And, you know, kind of a lot of the same culprits that we've talked about before are still in play. So whenever a developer downloads a pack or, you know, tries to install a package, you know, they go to npm install something. The attacker is using the fact that npm allows the author of the package to execute code directly on install to then try to do things like, you know, exfiltrate SSH keys or AWS keys, or now really exfiltrate source code directly, kind of just try to run a find and figure out source code of a bunch of different file extensions and exfil that out to an internet host immediately. So that's, those kind of common players are true across the quarters, and I don't want to say they're not interesting, they're just very consistent.
Very interesting. Yeah. People have to be extremely vigilant, I guess, when they're looking at packages and applications that are open source.
Yeah, this kind of culminated, sorry to cut across you. This kind of culminated this year where we got very good at teaching the system how to identify things that shouldn't be there. And that runs all automated, and the research team sort of teaches it new tricks over time. And as it detects things that are interesting, we'll kind of write those up and something that stands out or maybe a little bit unique. And that happened once earlier this year where we wrote up something that looked kind of unique. And then GitHub actually came and told us, hey, this is a threat actor we've been tracking for a while with a code name Jade Sleet, but actually was attributed back to North Korea, which was interesting in that that's the first time I'm aware of that someone has confirmed nation state activity in the open source software supply chain. I think we all knew it was there, but actually being able to like identify that was interesting, and I foresee finding a lot more.
Yeah, absolutely. I mean, it makes sense that nation states will unfortunately target this, right? When you've seen some of the large organizations that have been breached through open source methods. Right. So very shocking findings, very interesting. Let's shift gears a little bit. Let's talk about exactly how Phylum works. You've kind of alluded a little bit to how the technology works, but we'd love an overview on what Phylum does and how it does it.
Sure. Yeah, as I mentioned, like we're watching for new package releases all the time. And that's so we can really do as deep an analysis as we possibly can. Our goal is to always have an up-to-date understanding of the risk of using an open source software package before a developer ever wants to go use it. Ideally, we have that ahead of time. They ask us a question, we can tell them, should you use this or not? And that allows us to plug it into a variety of ways with how a user will actually kind of consume that data. We plug into the CI/CD system, pretty similarly to how lots of other security tools do. We also have an endpoint component that developers can use to actually wrap some of their interactions with these package managers. And that allows us to do things like, if I misremember the name or mistype requests in my example, right? We have a wrapper around what I might use with Python's pip. So I can say Phylum pip install requests, and if I typo requests and I land on a typo squatted package of Phylum's identified, it'll actually block me from installing that. And the goal there is that we see, 99% of the cases with attackers, they're trying to get you to install their package just once, so they can get this data exfiltrated and use that to go on and do other bad things. And we have to have some sort of gating mechanism to block that. So that kind of like lands on the developer endpoint. And yeah, with the automation tied into CI/CD, we're able to kind of help guide these decisions. Malware is kind of the easy one, the one that like jumps out. No one wants malware on their computer, but There's a lot more that goes into that that risk analysis, and then you can use a policy engine. We use OPA, Open Policy Agent, and that allows users or kind of the leadership of an org to say, this is what I find is acceptable use for open source packages, and start guiding making those guidelines that developers are then kind of enforced to follow. And the goal here is, one, we should have an acceptable use policy for what, it can't just be anything on GitHub, because anyone can put stuff on GitHub. But we have to have something sane, because to your point, the government's got involved, and we have to deal with SBOMs now. And knowing this, I like to think about it as building with the end in mind. So if I know I have to produce an SBOM that might be publicly available, or at least available to customers, I should be building to that end state with a goal, and using that policy engine framework is kind of how Phylum approaches that problem with its customers.
Yeah, very interesting. I think SBOM is definitely a four-letter acronym that blew up. No pun intended, but it's super important. But I think the detection and prevention on top of an SBOM is clearly what's going to drive down risk. So it's a very interesting approach. There's also an interesting risk methodology actually on the Phylum website. I was noticing. Can you maybe talk a little bit to that? And I think that outlines a little bit of the technology approach you just went into.
Yeah. So it's kind of it was the effort to figure out, of the set of things that could happen reusing open source code, or reusing untrusted code from strangers that we happen to affectionately call open source. What are the set of things that could go wrong, and how do we categorize those, and how can we envision that kind of domain? And that breaks up into kind of 5 large level domains: malicious code, author risk and reputation, software vulnerabilities, license issues, and engineering risks. So those are kind of the 5 domains that Phylum perceives the risk in open source software from. And you might notice the 2 of those actually kind of correlate with SCA products. We also, we look at software vulnerabilities and licenses as well. But we end up going a little bit deeper in some of those areas, because there's nothing easy in the open source supply chain. Like, if you look at licenses, it might sound like a boring thing to go look at. But if you think about it from the mind of a developer, if I want to install a Python package, I might look at its page on PyPI. Well, that license field is user defined. Doesn't have to say anything that correlates to a license, can say anything the author of the package wants. And then if I go to a linked GitHub repository, that might have a license, and there's no enforcement that those 2 licenses have to have anything to do with each other. And then if I go to the source code, there could be a license in the root or in multiple subdirectories. And there's, again, no enforcement between any of those components that they have to correlate. So that's kind of what I say about one of the challenges here, is that a lot of this is convention based. Like, a lot of good-hearted open source developers follow these conventions because they feel like it's a good idea. But there's not a lot of rules enforced. And as I think we know, that's a sweet spot attackers like to exploit.
Very cool. Awesome. So there is a Phylum integration on the Dazz platform. Would love your take on how you see our customers, mutual customers, making use of that integration. What are the benefits they're getting? Can you cover that?
Yeah, we were really excited to get the opportunity to work on that with Dazz. One of the things that is a little bit more challenging when you look at open source software supply chain from our lens is that not every fix is a simple upgrade. A lot of cases, if you find like an old package that has a bunch of vulnerabilities, well, the fix is to upgrade it to the newest version, which has less or none of those vulnerabilities. There are not always perfect answers like that. When you're talking about something that looks to have malicious code, usually you want to rip that out. Or maybe you found something where the author that's contributing to a package you use, there's a new author contributing to a package you use that has previously released malware. How do you handle that case? It's not necessarily a trivial, upgrade to a different version, so to speak. So having like a workflow element like Dazz can can do, that can take the data from Phylum, the things that we analyze, and then help customers tune a custom approach to how to handle some of these issues is really exciting, because it isn't always just, click one button, make the thing go away. Oftentimes there may be some thought that has to go into it, or some more analysis, and then taking them through that workflow so they're able to kind of keep track of everything, keep tabs on where the status of this issue is, and then ultimately resolve it, and do so at speed and scale is really exciting.
Cool. Yeah, we're equally excited, right? Open source is definitely a critical issue, but it's one piece of the puzzle in the Dazz view, right? If you have other vulnerabilities at the application level, at the configuration level, and at the cloud resource level. So putting that all together, especially powered by Phylum for our mutual customers, is, I think, something that's very compelling. So how can customers get started? How do they set up the integration?
Sure, it's wonderfully easy. All they need is an account with Phylum to have an API token, and an account with Dazz, and they enter the API token into Dazz. That enables all of the repositories that Dazz is knowledgeable to then be scanned by Phylum, and the data just flows right back into Dazz. It's about as easy as I think an integration can be. Just drop in an API token, and kind of get that deeper analysis data, and then the opportunity for how to act on it.
Awesome. All right, Pete, really enjoyed this conversation. I'll be sure to reach out back to you anytime I have questions about supply chain security. It's awesome to hear from an expert and to hear the Phylum story. So thanks so much for joining us today.
Thank you so much for having me on.
Appreciate it.
Thanks, everybody. Take care.
Cheers.